Okay, let's get started. Hi everyone, welcome to our Snack and Learn webinar today. We have Emilie here with us going to present in a second. Just a reminder, there will be time for questions at the end of the presentation. Feel free to log your questions in the question tab and we will address these at the end. So thanks and over to you, Emilie.
Thank you so much, and welcome to this Snack and Learn webinar. Thank you for joining, and I've been looking forward to tell you about how we work with CO2 reduction in construction projects. And yes, my name is Emilie, and I'm an environmental engineer and a specialist in LCA, and I work in a department called Climate Adaptation and Urban Development. And my primary work tasks is LCA and sustainability, and I'm from Denmark, WSP Denmark. So today's agenda is that I will present to you what are the typical projects we work with and a little bit about what is scope 1, 2, and 3 emission and why is it important. Then I will tell you why we think it's important to focus on reducing the footprint of our projects and what our reduction approach is using a tool called the carbon circle. And then I will present to you a case study, which is an example of how we typically work with the client on trying to reduce the footprint of the project. And finally, we will have time for some Q&A. So what kind of projects are we working on in our department and trying to reduce the footprint of? So first of all, it's climate adaptation projects. And that is what I mostly work with. We also have some urban development projects. And finally, we have some infrastructure project as well. So why is scope 1, scope 2, and scope 3 emissions important? Well, we know that we have had a lot of focus on reducing scope 1 and scope 2 emissions. And scope 1 emissions is the direct emissions from the industry and energy consumption. So that is, for example, CO2 emissions from when you're driving your car. And then scope 2 emissions is indirect emissions from purchased energy for example, light and heat and etc. But what about scope 3 emissions? I mean, we don't hear a lot about those and we don't focus a lot about how we're going to reduce these scope 3 emissions. And that is all remaining direct emissions, which includes project-related emissions. And that is what we are focusing on trying to reduce. That is especially project-related emissions. So then you can ask yourself, is there even a reason to believe that these project-related scope 3 emissions are high? So we know that in the building sector, 17% of embodied carbon emissions are emitted before the building is put into use. So this means all the construction work and all the materials are responsible for the main part of the footprint. And according to the Danish climate partnerships for the construction sector, they say that 10% of Denmark's CO2 emissions comes from the construction processes and production of building materials. And this figure you can see down here, it represents the scope 1, 2, and 3 emissions for a supply company in Denmark. And they have calculated their scope 1, 2, and 3 emissions. And here you can see that the dark blue one in scope 3 is the project-related emissions from a supply company. So this is, for example, materials and construction works and etc. So that's why we think it's so important that we gain some focus on reducing these emissions. So just to give you an idea of what is currently done in Denmark to reduce emissions, there is not any regulations in the construction industry, but we have in the building sector in Denmark has set requirements for reduction. And we expect that the same will happen in the construction sector eventually. And we hope that it will happen soon. So this is kind of just to show you like what were the first requirements they set. So they are increasing, or like the CO2 per square meters are decreasing every year. So the requirements are getting like tighter and tighter. And actually a couple of months ago, they tightened these climate requirements even more. So it's even more difficult to build a house, and you have to really focus on reducing the footprint. And we hope that this will, a similar thing will happen in the construction sector soon as well. So why should we work on reducing the footprint of our project? And this could kind of be seen as what can we use to like sell this to our clients? And we are very passionate about this, but how do we actually sell it to a client? So we know that in order to reach the Paris Agreement goal of keeping the global warming within 1.5 degrees, a dramatic reduction in our emissions of greenhouse gases is needed. We need to focus on this. And the footprint from project-related Scope 3 emission is significant in construction industry, as I just showed you. And as I said, we expect to soon meet demands for reduction. But right now we don't have any demands. So how are we going to actually convince our client to do this? And one thing we can say that is our experience with the type of projects we are working with show that within the construction area, there is often a possibility of a significant financial saving as well, if you're just open to rethink the project and do something else than business as usual. So you can actually save CO2, you can save energy and materials, and then you can save money. And that is something that most clients would like to hear. So some of the challenges of reducing the Scope 3 or the project-related Scope 3 emissions is that we need to define a baseline. We need to have something as a starting point for like where do we need to reduce. And that can sometimes be difficult as we want to get as early in as possible in these projects. So we want to make our goal the client's goal and how to turn our goal into assets in our sales strategies. That is another challenge. And we also need to see what methods and knowledge do we need to build up to reach these goals. So we know we need a method to optimize project in all project phases, so both early and later in the project phase. And we also need knowledge on the carbon footprint of various solutions and which materials and work processes especially contribute to this. So our approach when we are doing these calculations of the carbon footprint is the LCA approach. And LCA stands for life cycle assessment. And CO2 is not the only parameter in LCA. There is plenty of other environmental parameters. And as you can see here on the right, we have to make sure that we don't get this carbon tunnel vision. But often we see that carbon footprint is a good start, and carbon is often a good proxy for the remaining. Not in all cases, but in some cases. And you can use an LCA to document resource consumption, environmental impacts of products, systems, project plans, and strategies. And then you can use it to optimize project and compare different scenarios. So the three LCA phases we're calculating is the material production, then the transport of materials, and then the construction process. So another thing that's important to remember is that the optimization potential is different in the different project phases. So when we are over here early in the project progress, the optimization potential is high. And the further you get along in the project process, it gets more difficult to affect it and get involved in the decision making. So that's why we say that it's important to get in as early as possible, and that is another challenge that we sometimes face. But it's very important. And how do we approach this reduction? How do we optimize and reduce in our projects? So WSP Denmark has developed this methodology that we call the carbon circle. And this is what you see here. So we have some primary actions we can do in the different project phases. So we have the strategy phase, the planning phase, design, construction, and operation. And the typical engineer would go straight over here and see, okay, can we maybe use some green energy sources? Can we minimize the use of metal, and plastic, and concrete? So this is operate low carbon, build low carbon. But we would like the client to think more in the right side of the circle. So for example, build less. Can we renovate and use up remaining lifetime of this thing we might want to tear down or whatever? And can we postpone projects, maybe 5 years? Then we will save a lot of CO2. Then we can go a little further, see build for the future. We change that thinking a bit of building for the future. For we say we only need to build what is needed right now, and then build flexible so we can expand, not build more than is needed basically. And then if we go to build collaboratively, this could be engage and involve citizens. For example, just if you're building a new area for people to live in, it might be okay that there is a little water on the parking space a few times a year. So that could be a way of saying or involving the citizens. And then build wisely could be focusing on build on terrain, design for local conditions. So this is kind of the tool we are using, and I will give you an example on how we have used it. But when we have a project and we have defined this baseline of the project, we sit down with the client and then we go through all these phases of the circle, and we of course start on the right side over here, and then we see like how can we optimize. And these are just examples. There is many examples below each of these actions. So this is kind of like the different steps that we have with the client. So we, as I said, we start by defining this baseline scenario in collaboration with the client. So they need to provide us with data, and together with them we make assumptions on if there is data we can't get. And then I do the CO2 calculation of this baseline scenario, and then we have what we call a optimization workshop. So I present the baseline results, and then we see where are the hotspots, where do we need to focus on reducing. And then we discuss with the client these optimization options using the carbon circle. And then after the workshop, we, again in collaboration with the client, define this optimized scenario. And then I do a CO2 calculation of this optimized scenario to see what did we actually save from this. And what are the achieved reduction. And then finally, I, of course, also submit a document with results, graphs, assumptions, and the analysis. So now I would like to go through a case study where we use this approach, which I just told you about, and we use the circle. So the client was a supply company in Denmark, and we provided them with the service of this optimization analysis. So just to give you an idea of what this project was, it was an area of 13 hectares. And it was an area where they wanted to have a waste handling and a recycling site. They wanted to have a water facility, a heating facility, and then an administration center, and also water handling, like rainwater handling in the entire area. So what I did include in the baseline scenario, as we are only looking at like the construction part of the project, was establishing the construction site and removing it after use. Then I included the recycling site, the area for garden waste, then all the permeable paved area, and the handling of rainwater. So we didn't include the buildings, we didn't include the wastewater handling either, and also the containers. So this was the baseline scenario we defined, and this was the result. So it had a total footprint of 1,200 tons of CO2. And as you can see here on the graph, we see that asphalt especially is one of the hotspots, and where we thought had to look into and see how can we reduce the footprint of this hotspot. And also gravel, like the delivery and production of new gravel, but also the disposal of the old gravel that was digged up of the area. And then maybe also we could look into concrete elements and the paved area. Could we do something here? And the reason why soil handling is low, because that is usually a process that is quite high. That is because in this project they already implemented that all soil should be incorporated into the local area. So no soil was driven away. So that's why this one is so low. It's because they have actually in this project already done something to reduce the footprint. So we sat down with this graph and some other a little more detailed graphs, and then we used this carbon circle to see where could we reduce and optimize. And now I will present to you some of the optimizations actions that we discussed. So the first one is use of electrical building machines, and this reduced the footprint of with 60 tons of CO2, and this could be for construction processes like excavation of soil, installation of gravels, pipes and wells, asphalt, and of course soil to and from storage. Yeah. Another action could be reuse the gravel from the construction site. So when you're starting a project, you usually make this construction site with gravel. Maybe you can reuse this gravel for maybe around pipes or and other roads in this area. So we reduced the footprint with 156 tons of CO2, and we saved also 4,000 cubic meters of new gravel, which is a scarce resource. So that was quite good. And then we suggested them that they could maybe look into reducing the paved area. So they have this paved area for the recycling center. So maybe if you reduce the size with 20%, they could actually save 97 tons of CO2. Then there is a lot of materials that are CO2 reduced. So a lot is happening in this industry, and many new materials are coming. So in Denmark, we have a company called IBF, and they have created this CO2 reduced concrete. So if they were using this instead of regular concrete tiles, we could save 29 tons CO2. Then you could also look into the local soil that you are excavating. Maybe if you of course have to do some tests on this soil before, but we advise them to look into, maybe you could see if you can use this soil as an alternative to gravel around pipes. So this saved 160 tons of CO2, and it saved almost 7,000 cubic meters of new gravel, and that is gravel is a valuable resource, and we need to think of way to reusing as much as possible. Then we also suggested that they look into, instead of having main pipes like plastic pipes to handle rainwater, they could maybe use ditches as an alternative, and this could save 93 tons of CO2. So the total reduction after implementation of all these mentioned optimization actions and some few additional smaller actions I didn't mention here, but it gave a total saving of 46% or 653 tons of CO2. So this, and as I said, this is a project where all soil excavated is built into the local area, which was already a huge saving. So we were very happy with this result, and of course, this is a project where we only were the advisor. We don't know exactly what happened, but we showed the client the great potential of doing this. So to finalize this presentation, I'll just go through some key takeaways. So we are looking into a future with embodied carbon reduction goals in our clients' projects, and we must be able to make these carbon calculations with different degrees of details, and in early stages of a project and in later stages of a project. But as I said, it's important, if you really want to optimize and reduce the footprint of our project, we get in as early as possible. And this carbon circle can help the client understand it better, and it's a very good process, and it gives us the opportunity to reduce carbon in all project phases. And the carbon circle helps the client reduce the footprint and makes this, can't be a complex topic, but it makes the topic easier to approach and easier to understand. And we actually do experience great interest from our clients because we can present this concrete action-oriented approach. So one thing that I'll just say as the last thing before we go into questions is that we need to remember that calculations don't change your carbon footprint, actions do. So with that said, I'll go to the Q&A slides in here if you have any questions. And thank you so much for listening.
Thank you, Emilie. Fantastic presentation. Thank you for sharing with us this fantastic case study. So just before we move to the Q&A, please continue to log your questions in the question tabs so we can address them. I have a first question here. What would you say is the most important action when trying to reduce the footprint of a project?
Yeah, I would say like then we are on the right side of the circle. So if we can postpone project, that is, I mean, one of the best ways to save CO2 is to do nothing. But if we can just like postpone the projects, maybe just 2 years or maybe 5 years, we will have a lot more green electricity to be used, and maybe we will have the green or the what's it called, construction machines running on green electricity instead of diesel, and maybe there will be a lot more new products on the market where they have worked on reducing the footprints. So that is the biggest thing you can do. And after that, I will say if we get more concrete into specific actions, soil handling is one of the most powerful ways to save CO2. Like instead of driving it miles and miles away, try to see if you can incorporate it into the local area or in different projects in the local area that might need, that might need the soil. So that is a big saving.
Thank you. Another interesting question here is how can emissions be reduced in construction projects where the soil and water are impacted with pollutants? They say here impacted soil is usually excavated and sent to specific landfills.
Yeah, and that is an issue. And then, I mean, if you are dealing with polluted soil, you can't really do anything about that. You have to get rid of that, and you have to like buy new resources for your project if you need, for example, gravel. But what you could do is see, okay, what else can I do? Am I using concrete pipes? Can I maybe handle water on terrain instead of below terrain? That is something we're working a lot with in Denmark. Maybe there is some projects in the area where they are digging up the road, so they're removing the asphalt, and then I don't remember what it's called in English, but there is maybe 30 centimeters of gravel below the asphalt. They excavate that, and you usually just drive it away for landfill, but maybe you could use that instead of driving it away. But I mean, polluted soil is quite a challenge, yeah, and it's difficult to do something about it.
Thank you. Next question is what methods are used to measure and determine CO2 values and to select the best means to reduce levels?
So I'm not quite sure. Do you mean like which tools we're using to calculate the footprint? Maybe.
I assume so.
Yeah. I mean, we have two different LCA tools. So the first one is a Danish tool called Infra LCA. It's a freeware tool, where they have all these different emission factors for infrastructure related materials. So we have used that a lot, and then we have also used the tool called One Click LCA, which is a worldwide tool. It's not free, but then you have access to a lot of EPDs, and EPDs are like these environmental product declarations made by manufacturer of products. So they do this declaration of what is the CO2 footprint of, for example, a brick or 1 square meter of asphalt, for example. So that kind of data is what we are using a lot.
Thank you. Another question here about the case study. They say, I noticed that the case study didn't have the operational and maintenance carbon. The question here, was it considered or was it just small?
Yeah, we actually in this type of project there is some maintenance, but it's not a lot. I mean, if we are talking about instead of doing an asphalt road, we could do a gravel road, and then of course there will be some maintenance on that, and we did include it, but often it's not a very huge part of these projects. It's more when you're dealing with, for example, a house. There is, I wouldn't say, yeah, it's then you have more operational use for energy and water use and all that stuff. But we don't focus too much on that because it's a quite small part of it.
Thank you. There's a question here about postponing a project. How can you save CO2 by postponing a project in 5 years?
Yeah, so that was what I was telling a little bit about earlier. So when if we can postpone a project, if it's not necessary to do it now, or maybe we can renovate a little bit on maybe pipes instead of just removing them and installing new ones. Maybe we can renovate and then postponing it 5 years. Then in 5 years we might have an alternative to these concrete pipes that we're using now. So they might have developed concrete pipes with a lower CO2 footprint than we see today, and all the construction processes might be not on diesel but on green energy sources. So that is what we assume are going to happen. Of course, we can't see into the future, but I mean, this is a market where a lot is happening and very fast. So we see that there will be we think that there will be big savings by postponing projects.